first thing I noticed here, more than anything, when we're dealing with I, okay, especially when we're dealing with it in a fractional form like we are here, you've got to make sure we can't have I in the denominator. That's just one of the rules we've talked about. So the way that we fix that is that we multiply by what's called the complex conjugate. And again, I just put the section numbers here in case you want to go back and look at some examples that we've done there too. So what that fancy word means basically is I'm going to take whatever's in the denominator, I'm going to switch the sign in the middle, and some of you tried to multiply by a complex conjugate, but you didn't change the sign. Okay? So it could be something as simple as that. However, even when I get that part right, I've got to FOIL this out. And some of you are having an issue with foiling. When you're foiling, you're multiplying, which means these i's are going to take on the same sort of characteristics that a variable would. In other words, here, I'm like, okay, and I'm actually going to show you another organizational form for some of you here in a minute. For some of you doing this whole first, outer, inner, last thing, you tended to get confused and you missed some things. So let me pop a suggestion out here. If organization and keeping everything straight's an issue, one thing that I've done before with classes is I've taken each of my sets of parentheses, each of my quantities, and I've put them on the sides of this 2x2 box. And here's what it does for me. I have to fill every box with what I'm multiplying on the edges of it. And this way, if I'm foiling, I can't forget one. And I'll show you one other trick here for it in a minute. If I multiply each of the edges that I see here together, so I'm still doing the whole foiling process. But just a couple of things to make note of. First, I times I is I squared. And that's kind of important. We'll talk about that in a minute. But the other nice thing about doing this box is your like terms are always going to be in this diagonal. So where, like, if you forgot this was I squared and you just put I, you're going to be like, wait a minute, that isn't how this works. It's because it's just the diagonal it's supposed to be alike. So what I'm going to do here, and again, if I squared equals -1, that means I'd replace this with a -1. So -15 times -1 would actually be a +15. Now the I squared's gone. That's how it became the +15, because I replaced that in here. And now, oh, these are like terms, the -6 and the 15, so that'd be 9. And then 3i plus 3 more I would be 33i. And then I'd do the same type of thing down in the denominator again. And again, if you're comfortable with your foiling and you can FOIL that out, that's fine. But I'm just looking for those little things to help you where you're not losing the partial points here and there for this and that. And again, we're multiplying to fill it up. Multiplying by 1 is fun because it basically doesn't do much. So once I get the box filled up, 5i and -5i cancel. That's good. And again, this I squared being -1 means this is -25 times -1, which is +25. 1 plus 25 is 26. And if all three of these numbers would have been divisible by something, like if this would have been 27, they all would have been divisible by 3. If that would have been the case, I'd have had to have, worked that out, divided that out. But since it doesn't work for all, I can't reduce anything. It's not like I can take a 3 out of these and then just leave that. That's not the way this works. But you never can have an I left in the denominator when you're working on any of these. And for some of you, the big issue even on the test was it was plus and minus and you were still foiling. And I know we hollered about that several times. It's like only when you're multiplying do you start doing that stuff. So that's one thing that I'm going to try to kind of work back with you on. Another one from 5, was our old friend completing the square. Now, some of you are great at getting your vertex form set up, but then you'd forget about the other part because you were skipping steps. So again, I want you to show me what's going on here and not skip things. So when we're doing these, we want our variable terms isolated first. So if they're not, I need to fix that. Once I've done that, now I need to do my little trick with my b. So again, here's my b. b divided by 2, and square it. That's the value that's going to be added to each side of my equation. So I've got m squared plus 20m plus 100 equals negative 96 plus 100. Whatever I do to one side, I do to both. And for some of you, as simple as just like you moved the 96 over, but you kept it positive. It's little things like that you just got to watch out for. So now I'm ready to go into my binomial form. And again, to get that, just steal what your b divided by 2 was. And for some of you, when you skipped that, I think you forgot about it. Because I saw, like in this one, if this was the problem, I saw a lot of plus 20s here. And it should just be a positive 10. 10 times 10 is 100. 10 plus 10 is 20. And then my last part to this is to work on isolating my m value. Okay, the square and the square root take care of each other. Anytime I'm dealing with a quadratic, it's plus minus. If it breaks down clean, and this won't always happen, sometimes you won't be able to, but if you can break down the radical, you need to. And then I'll just minus the 10 over. And again, this is one of those exceptions. If this were like a square root of 2, I'd just be done. I'd circle it. But since I can simplify it, I'm going to. So I've got negative 10 plus 2 and negative 10 minus 2. And I get my two solutions. But it's little things like, can I break down the radical? Can I simplify it more? But in here, again, make sure you're showing where all that stuff's going, because it will help kind of make this click. And completing the square could come back up again. So there's something to watch out for. Quadratic formula. Couple of suggestions here. One, if you were having trouble remembering that, I noticed a few of you, especially the ones of you that got it on the test, a lot of you had it written up at the top of your paper. So I'm assuming you were probably trying to get it going through your brain, and as soon as you got your test paper, you're like, and that's fine. That's a good strategy to use. The thing I noticed most often for those of you that missed it, you forgot this was negative b. You had it as b, or you had plus 4ac here in the middle. So it's just one of those you've got to kind of work your way through it a little bit. But again, remember on this part, it's like vertex form. Okay, trying to find your x value of your vertex, and hopefully that'd help you with the negative part. If they're all on the same side, I'm ready to go already. If they're not all on the same side of the equals, I got to do that first. And our other big culprit, for some of you that had the formula but missed little things, the culprit's coming up here, but it's not going to have as much effect this time. Whatever values you are substituting need to be in parentheses, especially if it's a negative. If it's a negative and you don't put it in parentheses, you're going to get a negative answer, and it's going to be wrong. So you've got to make sure that you get all of those things down and then over 2 times a. Now at this point, I don't mind if you do this part on the calculator. I probably would recommend it for a lot of you, just to make sure that you don't run into something with a sign somewhere. All right. So, oh dear. I'm having all sorts of fun this morning. Ah! This will be fun to look at later. Seriously? Somebody can put this on bloopers later. Harty can't get the calculator to come up. There it goes. Okay. So as we talked about before, I'm going to type in what's underneath here, but I don't want to put the square root in right away because the parentheses are going to cause me trouble. So I'm just going to type in what's underneath. And then hopefully I can get something that'll work out nicer for me. Thank you. So I've got -7 plus or minus the square root of 217, which I will get this out of the way, all over 4. So what we're going to do here is I would want to double check and make sure that radical doesn't break down more. If it doesn't, that's going to be my final answer. But if it does, well, that's something I need to do. So I look at 217 and I'm like, okay, I'm just going to play with a couple of perfect squares just to make sure that I don't find something that works. So let's see. Oh, let's try 9 out. Okay, that didn't work. 16 wouldn't work. That's even. 25 wouldn't work. 36 wouldn't work. Let's try 49 just to make, oops. Let's try 49 just to make sure, because I know the other ones aren't. Okay, nope, that doesn't work either. So that's as far as this one's going. If my radical did break down, of course, I'd have to break it down. So sometimes that'll work out for me, sometimes it won't. But again, it's the formula is going to be my biggest help with that. And the nice thing with this is it works for everything. If I can't factor something, this works. And it doesn't get me stuck where I just put like IDK and go on with my life. Then finally, okay, sketch the graph of the function. And again, on something like this, I don't care if you did it with trying to factor it, if you tried the quadratic formula, if you graphed it on here. It varies on some of these, but the ones that seemed to cause the most trouble were something like this that didn't necessarily factor real nice. And sometimes they do and sometimes they don't. If you wanted to try factoring this, you can. I'll be nice and tell you in advance it's not going to, but if it doesn't and I go to graph it, remember, when I'm trying to find a vertex of one of these, and that's my key because then I can use the calculator for the rest of it, is going to be -b over 2a. Everything is in the right form here, my a, my b, and my c. So it's -b over 2a. So let's see here, -18 over 6. Okay, my x value is going to be -3. Now, my suggestion, if you have access to the graphing calculator, is to start using it at this point. If you don't, what you would do is to get your y, you'd take this and everywhere you saw an x, you'd put the -3. And any scientific calculator could take care of this for you. So basically, what we'd do at this point, we clear this out. If you were doing it this way, and again, I'll do like what I normally do. I'll let you see that both of them work. Because normally here I'd say go to the chart and get the -3 in the middle, and I should see symmetry, and I do. So I notice the middle of my graph is going to be -3, 1. And I'd put in my values that are less than greater. And for my non-graphing calc chart people, I will show where this is coming from anyway. If I were to plug this in to my regular scientific, so 9 times 3 would be 27, because again I used the parentheses. -54 plus 28 is 1. That's where my vertex is coming from. And then again, I would just plug some of these other values in to this to see what my other y values were. So it's not like it's impossible. So -3, 1. And again, I know this kind of, oh, I do have room. I was smart. Okay. So I get these on here. Now look and I say, okay, I notice a couple of things. It's or equal to, which means I'm going to have a solid line going through there. If it were just less than, it would be dotted. And remember before we talked about using a test point. We could use something inside to let me see how this works. So like let's say I use negative 3, 6, because I want to be right in the middle here. So if I were to test negative 3, 6, I plug in the 6 for the y value, and the negative 3 for my x. Now if you want to save yourself some time, remember, we've already plugged negative 3 in. When we plugged negative 3 in before, we got 1 out. So really, what this is asking me is 6 less than or equal to 1? Nope. So since it's not, we shade the outside, and hence comes the problem that some of you ran into at this point. Ooh, you want me to write the answer in interval notation. I can't just shade it. That's true. So here's how we tackle this. When you're trying to find solutions for these things, what you're going to do, and this is the part that gets tricky, because, and why do I have to do one like this? Because now I'm going to feel bad and I'm going to end up doing one of the homework ones with you because it did something that I didn't want it to do. Oh well. Normally when you're doing interval notation, you find the x-intercepts, which we normally would see on the outside edge here, and we'd go ahead and we'd use those to write our interval notation. So now here's how this is going to work. We look at this guy, and we talked a little bit about this before. Before, when we had less than on something, that was always like an and statement. So when it was an and statement, what we would do is we would take the intercepts and we'd end up with something a little bit like this. Let me bump this up a little bit. And statements were the ones where we'd have like parentheses or brackets and we'd be coloring in the middle. So like for instance, if this was 1 and this was 4, my interval notation would be from 1 to 4. However, if I took those same ones, and again, that's when it's something that's less than. When it was greater than, those were our ors. So if I had those same 2 points that I was looking at 1 and 4, but it was a greater than, they'd be going out from each other. So typically what happens then is you're like, oh, it's those ones where they go out and it's that really long interval notation. Yeah. So to go from like negative infinity to 1, and then 4 to infinity. And what I'm going to peek at here is on the other one, do I have one that's going to be nicer like that? And I do. You're going to get a freebie out of me on this. Because this one's an exception, because what's going to happen is, since it never crosses the x-intercept, since I can't get my x's here, this one actually, as far as a solution set, is going to be kind of strange. No zeros means I'm going to get imaginary answers, and I can't put that on a number line or do it in interval notation, so it would be kind of weird. So my apologies. I want to do one on here with you that's going to be a little bit nicer than that. So let me put this aside for a second. So when I tested these out, yeah, I want to go over 14 with you here in the packet. And again, so if you get one that doesn't cross, you don't have any real answers. So that's one of the things we're going to have to watch for here. So 14, let's take a peek here. See if we can get this one to treat us a little bit nicer. So let's get our x value of our vertex first. So we've got negative b over 2 times a. So negative 6 over negative 2 would be 3. And again, sometimes it's going to be a little bit easier to get this typed in on the calculator and use the chart and see if we're doing things right here. And I see my symmetry with my 3's, my 0's, and my -5's. So I'm feeling pretty good about things here. So, all right. Let's get these guys in here. Now this time I notice a couple of things though. This time I notice that it's just greater than, which means I'm going to have a dotted line for my parabola. That's going to give me another hint about what this is going to look like as far as the interval notation goes, but until I get there, let's do our test point here. 3, 0 looks like a safe bet down here in the middle. So if we test out 3, 0, let's see, my y value is 0. I already tested 3 in there. I got a y value out of 4. Is 0 greater than 4? No. So I'm not going to be shading inside. I'm going to be shading outside. And like we mentioned over on the note sheet, typically when we see the greater than, it's like an or. So I go back and I look and I see what my x-intercepts are. They're at 1 and 5. So basically, here's what I'm looking at. If I were looking at this on a number line, and I know it's an or statement, I know ors go out, sort of like my shading goes out and it doesn't stay inside. So if this were the graph you were seeing, what would the interval notation look like? We'd be going from -infinity until 1. And you are here too, because the shading goes beyond my graph, out here to the left. This one I would be parenthesing because I don't have the or equal to on that one. And then I would start back up again at 5 and go off to infinity. But again, the only time I can do the interval notation is if I have an x-intercept. If I do, I can do this. If I don't, I put no real solutions and I go about my business, because we don't do interval notation with i's. Okay? So, like I said before, your job is going to be on the rest of this test issues assignment. And again, whether you got 35 out of 38, 5 out of 38, doesn't matter. This is going to be on our next homework check. And again, I'll go through and I'll just be looking for answers. So you've really got to be careful and make sure you're not missing little things here and there, because that could end up, dinging you and you do everything else right and then you forget one other thing. So use the note sheet, go back and look at some of the sections. Hopefully this helps a little on some of the ones you missed on the test. I tried to make some little notes if I could figure out some little things, and if you were way out there, I basically left it be and would suggest looking at the review video or the review key again, or your review period, to try and see how it is, and then schedule a time with me to give that another go.